All right, Pre-Calc kids, EOC basics, or sorry, EOC challenge exam basics 3 practice. All right, so the first one's changed a little bit. We're just going to move that over. I'm pretty sure everybody had gotten the first question, right? So we have to set this equal to 0 because that's what you do with a quadratic. And then we're going to try to factor this thing. This should factor. I'm going to pull a 3 from everything. Because I feel like that's going to make it easier. And I'm pretty confused about what's going on here because it doesn't look like that factors, does it? I wonder if I made a mistake on that one. It should be something else. Okay, so yeah, this problem's not going to work. I don't know if I've got a typo or what here, but we need to fix that. It can't be negative 36. It's supposed to be, I feel like it's supposed to be negative 33. So make that a negative 33. I couldn't tell you what happened. So anyway, starting over, we're going to add 33x to both sides. We're going to take away 12 from both sides, and we're still going to pull the 3. That'll factor. That will factor. You got your 3 on the outside. It takes an x and an x to factor the trinomial. This is the trinomial. And it takes a 3x. What happens to that 3 there? I am exhausted. I need a positive 11, and this should work. The outside's going to make 12x, the inside's going to be minus x, and 12 minus 1 is 11. So here's the factorization. Using that ZPP, 3x minus 1 is nothing. Add 1 to both sides. Divide by 3, x is a third, or x is negative 4. So either way it works. 2 is a factoring example by and large. Find the zeros of x to the 4th minus 81. So when I look at this thing, I see this pattern of mathematics. It's an a squared minus a b squared pattern, which factors as a minus b times a plus b. I've also done so much factoring in my life, I don't need that pattern anymore. But to create x to the 4th, even if you don't memorize this pattern, it's not a big deal. It takes an x squared and x squared. To create an 81, it's going to take 9 and 9. Now notice that if you FOIL it, check with FOIL. Plus 9x squared minus 9x squared, nothing in the middle. You're not quite done. This guy will factor some more. It's x minus 3 and x plus 3 by the same logic as this one. And then we have x squared plus 9. So ZPP kicks in, x minus 3 is a 0, x plus 3 is a 0, and x squared plus 9 is a 0. Now these guys are simple. X is 3, x is negative 3. This one, you got to do this tiny bit of work. X squared is negative 9 by jumping over. I know it's imaginary. It's the imaginary plus or minus the imaginary root of 9. And I know that the real root of a real 9 is 3, so plus or minus 3i. 4 zeros, 4 zeros. Factor this one. This would be your factoring by grouping example. I can pull an x squared from the first 2 pieces. I'm left with x minus 5. I can then turn around and pull 25 from the back 2 pieces. Notice I pulled the negativity because this factor had to repeat. It repeats, has to. The common factor is x minus 5. The crap left over is x squared minus 25. This is a factorization. It'll probably be multiple select. X squared minus 25 factors as x minus 5 times x plus 5. And that's a good factorization, and this could actually be written as x minus 5 squared because that factor happened 2 times. Also a good factorization. Lots of things going on there. All right, what's different about this one? It's 1/8 to the negative 2/3. So it's a little different than the last one. I want you to think about this property. Okay. Think about that. And also think about what it would be like if the exponent was negative. I'd flip it. What you have here is you have 1 over negative 2/3, because you can kind of think about the distributive property, sitting pretty over 8 to the negative 2/3. And we can swap these places around, can't we? That negative exponent, saying move it to the other side of the divisor where it's positive. So you have 8 to the 2/3 up top over 1 to the 2/3 down low. Now this is also x to the power over root, which I think you have down. You know, this guy is the cubic root of 1 that is squared, which is just 1. The top part is the cubic root of 8, and you turn around and square it. Cubic root of 8 is 2, and when you square it, you get 4. Started off as a fraction, ended up as a nice whole answer. As a class, you guys are kind of sucking on this. You're going to write 2 equations. The first one is as is, and the reason you guys aren't doing so hot is probably because you're not watching this video. Or we change signs. 4x plus 2 less than or equal to 8. And then we just do math. We add 2, we get 10. Negative 4x is less than 10. Divide out the negativity, flip the inequality. If I divide 10 by negative 4, I get negative 5/2. Subtract the 2, I get 6. Divide by 4, I get 6 over 4, which is 3/2. So I'm greater than or equal to negative 5/2, and yet I'm less than or equal to 3/2. Hopefully you understand this. I'm everything in between. I'm everything in between. That's what I am. All right, moving forward. Number 6, determine the intervals on which f of x equals 5x squared minus 13x minus 6 is negative. All right, easy peasy. We just have to factor. It's your favorite F word. You and I both know it is. I feel like 3 and 2 is probably my numbers here. It's negative, so it's going to be less than 0. It's a big deal. By using ZPP, I have an x-intercept at 3 and an x-intercept at negative 2/5, and you're supposed to graph. 5x squared starts high, ends high. We cross at 3 and at negative 2/5, which would be like right here. So we always think about the graphs, and this is the negative territory. I am negative so long as I am literally stuck between negative 2/5 and 3. As an interval, negative 2/5, comma 3. All right, moving on. Use the decimal approximations of the local maxima and minima to determine the intervals on which the function is increasing. It's going to be this path and this path. So I am increasing from where x is negative infinity all the way up to that funky looking decimal. Like this one, I don't think more than 3 people out of your class got this right on the last quiz. It's the easiest stinking problem on the whole quiz. Union with 2.41421 all the way to infinity, because you're moving right. You guys are throwing x's and y's in this thing, which means even though you're not going to watch the video and I'm going to write out and waste time typing it, you are finding the values of x for which y is increasing. Or not find, you are stating would be the better wording. Everybody's supposed to get this right. This one's a little rough. I Identify the transformations, and I gave you a quadratic here because I thought you might have more luck here, and you see what goes on. What has happened? Well, lots of things have happened. The thing has been flipped. We're supposed to apply this order BHAK. B is going to be the horizontal stretch or reflection. H is going to be the horizontal shift. A is going to be the vertical stretch / reflection / yeah. And then K is going to be our vertical shift. And this is the order you're supposed to do things here. So this one I made nicer numbers because the last ones were kind of bothering me myself personally. Because I like numbers. Because the reason I like numbers is because I can look at this equation and I can tell you that its equation should be -2 because I fall 2 and run 1 times x plus 5 quantity squared and then take away 4. So what's it take to become that? All right. While I'm at it, I may as well do this one. This one is f of x equals slope of 2, rise 2, run 1, x minus 3 quantity squared plus 4. So what all happened? All right, so there isn't a B. There's no evidence of a horizontal stretch reflection. There is a horizontal shift. So the first thing we did is we took f of x and we shifted it all the way to the left. All right, we shifted it. We actually subtracted 8 from 3, so it's actually x plus 8. Fun times. That takes care of that. Now the next thing is the vertical stretch or reflection, and this is where I'm afraid I might have been messing up earlier. G of x is negative f of x. So yeah, this is what's bothering me. I knew I was kind of messing these up. This doesn't change anything. But negative f of x, all right? I'm currently at f of x plus 8, whatever. I have to negate the whole blasted thing. We're getting lucky and things are working out here quite well. But I have to negate the thing. Which isn't a big deal. I'm trying to see if this lines up with how I've been showing you in past videos or not. No, because if we reflect it, you're fine. So that's good. Now, think about what would happen if you reflected this thing. If all you did was a reflection, if you reflected it, it wouldn't be at 3, 4. It would be down over here at 3, -4. Okay, so I have been showing you guys wrong. This would be at 3, -4, and it would open down. It doesn't need anything else. The negative symbol is reflection, and it is negating the entire function. That's what gets, and it gets me after all these years too. That reflection negates the whole thing. That's what it does. It negates the whole thing. So when you talk about being negative f of x plus 8, you're actually negative f of x plus 8 on the inside, but the outside was, oh, why do I have plus 8 there? plus 4, plus 4. And you have to negate the whole thing. And I'm sorry about this because I know that adding all this extra stuff in it just really makes it worse. That's going to give me negative f of x plus 8 minus 4, which is exactly what I have here as the minus 4. So in reality, the only things that happened to do this transformation was that right there. That did it. And boy, that stinks, doesn't it? That really stinks. There was no adding or subtracting to move it around. You just flipped it. You reflected it. You negated the whole thing. And there you go. Anywho, and maybe you can see it as the signs changed. It was just a multiplier of a negative symbol. All right, last one because the bell's already rang. Quadratic has a vertex of 2, negative 5. Determine the vertex of the quadratic after the transformation, f of x minus 2 minus 5. And remember that this is actually a right 2. That's all it is, not that it matters, but you can literally follow this. 2 minus 2 is 0, and then we're going to take away 5. Negative 5, take away 5 is negative 10. And that's that. And I need to be going because I got stuff to do.